Hi guys, we are going to take a look at 10.3 today, which is areas of regular polygons. So let's remind ourselves what regular means. That means congruent sides and angles. So that's where a regular polygon comes from. And we should be able to find the area by the time we're done. So let's take a look at some vocabulary. So remember when we put a circle around a triangle, we called that circle a circumscribed circle? Well, we can do that for any regular polygon as well, so that we can find the center of the polygon. Because the center of the regular polygon is going to be the center of the circle as well. So my center of circle and regular polygon, which then can lead us to what is called the radius. So as we know, from the center to the circle edge or the circumference, then that becomes your radius. But for us, our radius is going to be from center to a vertex. Is the same as the radius of the circle. So the radius of the polygon is from the center to the vertex of the polygon. And then we have a new term today, which is called the apothem. This funky word is the perpendicular distance from center to side. So we know finding distance is always perpendicular anyway. So we are looking at the apothem is from the center perpendicular to the side of the regular polygon. We also know that the apothem will bisect the central angle. So this is my central angle of a regular polygon. We'll recall how to find that central angle shortly. But we know that the apothem will bisect or chop that angle right in half. So that's going to lead us to some of our special triangles, 30, 60, 90 triangles. Let's see, what else we got? Since we know that these are all radii that go from the center to a vertex, we can see that all of these triangles, wedges within the regular polygon, are isosceles triangles. So this highlighted area here, these are all isosceles triangles because they are formed by two congruent radii. So that'll be a useful fact. So when we're looking at these, if I can find the area of just this isosceles triangle, I can take that area and multiply it by 1, 2, 3, 4, 5, 6. The number of sides in the polygon will determine how many of these isosceles triangle wedges are inside that polygon. So that's a separate method we could use too. So generally speaking, though, we have a relationship between the area of a polygon, a regular polygon. So the area of a regular polygon is related to the distance from center to side, aka apothem, also known as the apothem. So there's a relationship between the apothem and the area of this regular polygon. So let's first start taking a look at finding angle measures though. If I want to find measures of angle 1, 2, and 3, first we need to find the central angle measure, which is angle 1. So we are going to have 1, 2, 3, 4, 5 central angles here, created by our radii. In order to find those 5 central angles, I know the measure of angle 1 is equal to 360, we learned this earlier in the year, divided by the number of sides, which is going to give me, 72 degrees. So each of these triangle wedges has 72 degrees as the whole central angle. We know that the apothem bisects the central angle. So we know the measure of angle 2 is going to equal the measure of angle 1 divided by 2, or 1/2 of the angle 2. That's going to equal half of 72, which is 36 degrees. We can also find the measure of angle 3. So I know that I have an isosceles triangle, and therefore the base angles are congruent. So I know the measure of angle 3 is equal to 180, the total sum of triangle angle measures, minus the 72 central angle that we're already using, and divide that result by 2 will give me my base angles. It's equal to 54 degrees. Base angles of isosceles triangles are congruent. So we took this whole 180, subtracted the 72, and then divided by 2 to get the 3 and the 2 base angles. Okay, so let's try this one. So I can see that my radius goes from here and then all the way across. So this must be a diagonal. So I must be chopping my polygon, my regular polygon, in half. So if I have 1, 2, 3, 4 sides showing, I know I have 8 sides total. So in order to find the measure of angle 1, which is our central angle, the measure of angle 1 is equal to 360 divided by 8. 360 divided by 8 is 45 degrees. Then we want to take a look at the measure of angle 2. Well, the measure of angle 2 is created by the from the center perpendicular to the side created by the apothem, so we know the measure of angle 2 is going to be half of the central angle, which is 22.5 degrees. And then we're just left to find the measure of angle 3. We know the measure of angle 3 is a base angle, so we got the measure of angle 3 is equal to the entire sum of the triangle minus the central angle divided by 2. And we end up with 67.5 degrees. Alright, you should pause the video, try the next one, find those angle measures, and then come back, check your answers. Okay, there are your angle measures for your practice problem. Let's start taking a look at developing the area formula. So first we want to talk about the congruence postulate. So if two polygons are congruent, then they have the same angle, same area. So that makes sense. So if we take a look at this figure below, we know we go from the center of the polygon to the vertex, so this must be a radius. We also know that the radii divide your regular polygon into n congruent isosceles triangles. Okay, so we talked earlier that, hey, my radius chops these into segments that are isosceles triangles, and so however many sides or how many triangle wedges I'm going to have. So we know that each triangle has area of 1/2 base times height. If we look at our base times height, though, our base is our side length, so we can replace B with S. And we know our height is the perpendicular piece, and that happens to be our apothem. So we can rewrite the area formula as 1/2 apothem times the side. So just as a reminder, A equals apothem. That's our new word. That's the perpendicular distance from the center to the side. So this leads us to an n-gon, so however many sides. Area is A equals 1/2 AS times however many sides there are. Because this is the area of each triangle times the number of triangles that are in that n-gon. But we also need to take a look at perimeter. So if we're looking at the perimeter of an n-gon, it is the side length times the number of sides. So side times n. Side length times the number of sides. Well, if we look at our formula for each of the area triangles, we see that we have apothem times side times the number of triangles. So S times N, which is the same thing as S times N. So I can substitute S times N back in. So I'm going to substitute Sn into the area formula that we derived above, formula, to get the area is equal to 1/2, so that's the 1/2 where that's coming from, A, which is our apothem, and then the Sn is the Sn, which we decided is just the perimeter, so P. So now that we've derived the formula, we're going to use the formula. So let's take a look, because it's easier once we start applying this to understand what's going on. So the area of a regular n-gon, remember n just means drop in the number of sides. So 6-sided, 5-sided, 4-sided, 3-sided, and so forth. We've just derived the formula as the area of a regular polygon is equal to 1/2 AP, where A is my apothem. That's the perpendicular distance to the side. And P is the perimeter. That's the number of sides times the side length, n times S. So let's take a look at how we can use this. We want to find the area of a regular polygon. We are given from the center perpendicular to the side. That's the whole side, so that must be my apothem. And let's figure out how many sides we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I always put my congruence marks on there because it makes it easy to count how many sides in the polygon, and it's regular, so we know they're congruent anyway. So step 1. Find perimeter. We know the perimeter is equal to the number of sides times the side length. So we know in this case I have 10 sides times, they gave me 8 inches each, so my perimeter is 80 inches. Step 2 is to use the formula. Step 2. Use area formula. So, that was 1, this is 2. So area equals 1/2 apothem times perimeter. So 1/2 apothem they gave me is 12.3 times the perimeter we just calculated up above is 80. So when we substitute that into our calculator, we get 492 inches squared because we're dealing with area. All right, let's try another one of these. Let's take a look at what is the area of a regular pentagon. So pentagon, I know, is 5 sides. with an 8 centimeter apothem and 11.6 meter sides. So I know my apothem goes from the center perpendicular to the side. So that's going to be my 8. And I know my side length is 11.6. We need an apothem and we need a perimeter. So we need to find, step 1, the perimeter. The perimeter is equal to n times s. So remember, when you're using a formula, write the formula down, then substitute in the pieces. The number of sides is 5. Each of those sides is 6, so our total perimeter is 58. Second step is to use the formula. A is equal to 1/2 apothem times the perimeter. Substitute in the pieces I know. The apothem they gave me is 8, and perimeter is 58. Calculate that out and you get 332 centimeters squared. So these aren't too bad. If you already know the apothem and the side, then they're pretty easy. You use them to find the perimeter and you substitute some stuff and use the formula. If the side of a regular polygon is reduced to half its length, so I chopped the side length in half, how does the perimeter of the polygon change? Well, that makes sense, because if I chopped this in half, then I'm going to multiply that by the number of sides. Well, I've got half as much, so your perimeter is going to be half as much. So perimeter is also reduced by 1/2 because the original perimeter is n times s. The new one is n times 1/2 of s, because we chopped s in half. So we can rewrite that as 1/2 ns, which is half of the perimeter. So that's a good quiz or test question right there. You're going to try the next two, but you're missing some information. So jot down what the apothem is. The apothem for this figure over here is 8 rad 3. And the apothem for this figure over here is 1.5 rad 3. So I want you to leave in radical. All right, pause the video, try those couple, and let's see how you do. Okay, there are your answers for your practice problems. I needed to first find the perimeter, then I needed to find the area. Once I found the perimeter, I just substituted in the given apothem and simplified. So remember, when you're multiplying by radicals, this stuff up in the front is multiplied together and your radical comes along for the ride. So half of 96 times 8 gives me 384. Same over here, my apothem was 1.5 rad 3, so I substituted it in for apothem. I had to find my 3 times 6 sides to get my perimeter, and I end up with 13.5 rad 3 inches squared. So make sure you jot down your questions so that we can talk about them tomorrow. Okay, so those are pretty easy when you have the apothem. What gets tricky is when you have to go find the apothem, when you don't know what the apothem is, or you don't know what the short leg or long leg pieces are. So that's where our special right triangles come in to find the area. So, for example, a honeycomb is made up of regular hexagonal cells. So we know this is 6 sides. The length of the side of the cell is 3 millimeters. What is the area? So I have a 3 millimeter side. In order to find the area, we need perimeter and apothem. Those are the two things you need in order to find the area. So we got to start finding the pieces. So let's drop in some information. We know that the center creates central angles that are congruent. It's 360 divided by 6, which means that these are all 60 degrees. So I know this angle here is 60 degrees. I know that the apothem goes from the center perpendicular to a side. And I know that the apothem bisects the central angle in half. So I know that if I were to drop in a radius here as well, that angle is going to be 30 degrees. So if I rewrite this triangle, I'm going to rewrite just this triangle here. I end up with a special right triangle. That's 30 degrees. So if this is 90, this is 30, this must be 60. This piece here, the perpendicular piece, is still my apothem. It's also my long leg because it's across from the 60-degree angle. And I know my 30-degree side is my short leg, and my short leg is that piece right there. So the short leg is going to be half of the whole side. So I know my short leg in this case is 1.5 because the whole side length is 3, so my short leg is 1.5. So I can find my perimeter because I know the side length. So I'm going to start with my step 1. Perimeter equals n times s, which is equal to the length, the number of sides, 6 times the side length, which is 3. So that's equal to 18. My second step, though, is area equals 1/2 apothem times perimeter. 1/2, I know the perimeter is 18. I've got to figure out what this apothem length is. So if I go back and look at it, the apothem is the long leg. That's where our special right triangle stuff kicks in. That's my apothem. It's the long leg of my 30, 60, 90. So I need to use my rules for 30, 60, 90s. So I'm going to go over to the side and I'm going to go find this apothem. So I know in a 30, 60, 90 that the long leg is equal to the short leg rad 3. Substituting the pieces. The long leg I know is the apothem. The short leg we know is half of the side length, which is 1.5. And it's rad 3. So now I know what my apothem is, and I can use that in my formula. So I'm going to substitute 1.5 rad 3 into the area formula. And that means half of 18, which is 9. 9 times 1.5 is equal to 13.5 millimeters squared for my area. So if we go back to your practice problem, that's really what we got on that as well. Because we were, in that case, given the apothem of 1.5 rad 3, and we found the area of 13.5. So here we worked backwards and figured out the area. We had to figure out the apothem that was given earlier. All right, let's try these again. So you are planning a mural of colored equilateral triangles. The radius of each triangle is 13.7. What is the area of the triangle to the nearest inch? Okay, so we want to take a look at this. So we know it is an equilateral triangle, which means these are all 60. We know that this central angle created, here's my central angle, this whole angle here is 360 divided by the 3 sides that I have, which gives me 120 degrees. So I know that the apothem, which is the perpendicular from the center, perpendicular to the side, bisects my angle, my central angle, so I know this has to be a 60-degree angle. We have a 30, 60, 90 triangle. So we know we need the perimeter and we need the apothem. So let's go find the apothem. So we know that we have a 30, 60, 90 triangle. We know the hypotenuse is equal to 2 times the short leg. We also know that the long leg is equal to the short leg rad 3. So let's go see what pieces of information we have. Right now, if we take a look at this, I'm going to redraw it so I can see it better. I know that that's the right angle. This is 30 degrees, so this is the short leg. They gave me the hypotenuse of 12.7. And this is 60 degrees, so this is going to be the long leg. because this is the perpendicular piece to the side of the regular polygon, I know that this short leg is also the apothem. So I need to solve for the short leg. So let's take a look. We have the hypotenuse equals 2 times the short leg. That's handy. So the hypotenuse is 12.7 equals 2 times the short leg. The short leg in this case is A, which for the apothem. Divide both sides by 2, you get 6.35 equals A. Okay, so I have the apothem. I need to find the perimeter, which means I need to find the short leg piece, the long leg piece, because it's opposite the 60-degree angle. The long leg piece is going to give me half of the whole side. So I'm going to find the long leg and double it by 2 so I can get the side so that I can then find the perimeter. So if I have the long leg, I know that it is equal to the short leg, which we found as 6.35 times rad 3. This whole side is equal to 2 times 6.35 rad 3, which means 2 times 6.35, which is equal to 12.7 rad 3. I wonder if that's always going to hold true or not, where we ended up with the hypotenuse being the same length as twice the leg. We'll find out. So this is our side. And so we can go and jump into our steps. Step 1 is perimeter. Perimeter equals n times s. The number of sides is equal to 3. The side length is 12.7 rad 3, which is equal to, they want us rounding. So I'm not going to round yet until I get to the area, 38.1 rad 3. Step 2 is to find the area. Area equals 1/2 AP. Substituting in the pieces I know. 1/2, the apothem we went and found over here is 6.35 times the perimeter, which is 38.1 rad 3. When I put that in my calculator, I get approximately, to the nearest nearest inch is 210 inches squared. So these are the ones that get tricky. You've got to watch what pieces you're looking for. It often helps to redraw the figure, the triangle that we're pulling out for the special right triangle. Okay, let's do another one. Find the area of the regular polygon with the given radius or apothem. If your answer is not an integer, leave in simple radical. So we want a simple radical. So we are given from the center, if I follow it down, it goes to a vertex. So that's going to be a radius. So I need to drop in my apothem, which is perpendicular to the side. I know that I have a 1, 2, 3, 4, 5, 6 six-sided, so 6-sided. 360 divided by 6 is 60. So I know that I'm going to redraw this so I can see it bigger. Get my stuff out of the way here. This is my special right triangle, so I know that's a right angle. I just found that the apothem cuts the central angle in half, so that's 60. So this is going to be my long leg. So that's not 60. The whole angle is 60. So this is 30. Sorry. 30. So this is 60. So this is my short leg. I need 2 of my short legs to get me to the whole side, because that's this piece right here. There's this piece right here. And I know that this is the long leg, and it's also equal to my apothem. So I just got to go find some pieces. So I'm going to start with my 30, 60, 90s. I have 30, 60, 90. I know the hypotenuse is equal to 2 times the short leg. They gave me the hypotenuse of 6 rad 3 is equal to 2 times my short leg. So divide both sides by 2. I get my short leg is equal to 3 rad 3. I know that 2 of my short legs over here equals the whole side. So 2 times 2 rad 3 2 times 3 rad 3, carry that number down, equals my side. So 6 rad 3 equals my S. I still need to find my apothem. So that's my long leg. So I know my long leg is equal to my short leg, rad 3. Long leg in this case is the apothem, so I'm going to substitute an A. Short leg we just found is 3 rad 3 times rad 3. Now remember the algebra. Rad 3 times rad 3 is the square root of 9, which is 3. So 3 times 3, A equals 9. So now I have my apothem, I know what my sides are, and I can find my perimeter. So we go back to our 2 regular steps, and we go step 1, P equals N times S, which is equal to the number of sides, which is 6 times my side length is 6 rad 3. 6 times 6 is 36 rad 3. My area equals 1/2 AP, which is equal to 1/2 our apothem we found as 9, times my perimeter, which we just found up here, is 36 rad 3. Half of 36 is 18 times 9, that's 162 rad 3 meters squared, because it said to leave it in simplified radical form. Okay, you've got a couple that you are going to try. You should start with the original figure, sketch in the pieces you need to do, and then break out a smaller segment piece of your special triangle if you need to. Pause the video, come back and check your answers. Okay, there are your answers. Make sure you check your work, follow through, come to class ready with questions. We'll see you tomorrow.